You have seen here that the reflection of a pulse means the bouncing back of the pulse when it incidents on a boundary. The boundaries are of two kinds. One is the fixed boundary, from where the reflected pulse and incident pulse have 180-degree phase shift, and the second one is the open boundary, from where the pulse after reflection suffers no phase change. So here, as you can see, there is no phase change in the phase in which the pulse is going. It will return back at the same phase. Then we studied the interference. There are two kinds of interference. One is the constructive and another one is the destructive interference. I am creating a pulse and I am creating a second pulse. When these two pulses meets with each other in the same phase, then what will happen, will find a constructive interference, and they are meeting in the opposite phase. You can see this particle was not feeling any of the displacement. It was destructive interference. Yes, here as you can observe, this particle, when you will find that this particle was not having any displacement, so it was destructive. You will see this particle, okay, again back, this particle was not suffering any displacement, because here destructive interference occurs. This pulse is in opposite now it is in this direction and opposite direction. If you just try to focus your imaginations, if you try to focus here at this point, you will find that during this there is no displacement, because here there is destructive interference, and this particle will suffer a constructive interference, because here the particles, the waves are moving, the meeting in the same phase. I hope it is clear to you. The next, I have taught you reflection of wave. I have taught you the constructive interference and destructive interference of wave. Now I will teach you a third most important point, which is standing or a stationary wave. Standing wave is something which is created when uh, a pulse goes, second pulse, third pulse, fourth pulse, fifth pulse, a wave is created, and now what is happening, these waves, I am creating these waves. For example, the incident waves and the reflected waves are what, superimposing each other, and it creates a special pattern called the standing waves. It is more clear when I take a fixed end, because here you will find that I am assuming a fixed boundary. So if I create one pulse, second pulse, third pulse, fourth pulse, and I'm creating some kinds of pulses, let me do it again. So what is happening here, the waves will reflect back and the pulse will reflect back, and we will find a spatial pattern of wave. This is called a standing or a stationary wave. What is so special about stationary waves, there are few particles which will not suffer any displacement, and there are few particles which will suffer maximum displacement. It is more clear when I will create a self oscillating pulse, a uniform pulse. You will find, I will show you when they will meet with each other, after a few seconds you will find there is a standing wave pattern created. This particle is at the same place, it is not suffering any such kind of displacement, but there are some particles you will find that which are suffering maximum displacement. Let us see it again. I am just increasing the frequency and some amplitude also, and then when I start it, what will happen, you will find when a standing wave is created, you will find now here, yes, standing wave has been created, because when it is created, incident pulse is going, and reflected pulse, incident pulse, reflected pulse, they both meets with each other and we get a wave called standing wave. Here, after making some pulse, I just make it stop. Okay, I'm for example, here it is moving. Let us suppose after creating one pulse and it doesn't move, right? Then what will happen, you will find wave will be there, right? Here you will find that this particle is having displacement, this particle is not moving. It will happen, this particle is at rest, this particle is moving. So the particle which is not moving, that point is called node, and the particle which is suffering maximum displacement is called antinode.